Hello, welcome to the stream. My name's Jared. I run a software consultancy where we build Ruby on Rails e-commerce systems. Today, as with every night that I'm free until Christmas, we're working on Advent of Code problems. Last night, what was last night's problem? Last night was counting lanternfish, which was a bit of an optimization problem. Classic one where we're given a we were led into a solution in part one, and then in part two it was demonstrated that it would not, the sort of naive solution would not work, and we need to come up with something clever, optimize it a bit. Struggled a little with the the exact details of it, but we got there. We had the right idea. I just fumbled the execution. So we're here. Day 7 about to go live. Nice, Jay. Kicking off the Advent of Code. It's fun. All right, day 7, the treachery of whales. A giant whale has decided your submarine is its next meal, and it's much faster than you are. There's nowhere to run. Suddenly, a swarm of crabs, each in its own tiny submarine, it's too deep for them otherwise, zooms in to rescue you. They seem to be preparing to blast a hole in the ocean floor. Sensors indicate a massive underground cave system just beyond where they're aiming. The crab submarines all need to be aligned before they'll have enough power to blast a large enough hole for your submarine to get through. However, it doesn't look like they'll be aligned before the whale catches you. Maybe you can help. There's one major catch. Crab submarines can only move horizontally. Of course they can. A quickly made list of the horizontal position of each crab, your puzzle input, you quickly make a list of the horizontal position of each crab. Crab submarines have limited fuel, so you need to find a way to make all of their horizontal positions match while requiring them to spend as little fuel as possible. For example, consider the following horizontal positions. This means that there's a crab with horizontal position 16, a crab with horizontal position 1, and so on. Each change of step 1 in horizontal position of a single crab costs 1 fuel. You could choose any horizontal position to align them all on, but the one that costs the least fuel is horizontal position 2. That makes sense. This costs a total of 37 fuel. This is the cheapest possible outcome. More expensive outcomes include aligning at position 1, position 3, position 10. Cool. Determine the horizontal position of the crab that the crabs can align to using the least fuel possible. How much fuel must they spend to align to that position? Get your input. It's big. Yeah, cool. I have a thing that automatically downloads it when I try and solve it. So let's take our example and write a test around our example. That's not our example. I'm just bad at copying things. And we established that the horizontal, the solution is 2. I'm just thinking through the problem. I mean, for small enough input sizes, we can scan it. Like, what's the biggest number in here? 1048, 1400. I mean, we can just scan the whole space, realistically, and just figure them all out, right? Let's try that to start. I suspect it'll work for part 1, might not work for part 2, might be one of those type of deals. All right, so our crabs equals input, split it on the commas, map it into integers. So we have an array of numbers now, and we know our solution is going to be, let's just quickly, I'm going to have to do the thing I did before. Day 7, part 2. That's just, it's boring. I won't explain why I just did that. So we run our specs, get in here, we got some crabs. Now is it min, oh, crabs.min, crabs.max, cool. So we can iterate from crabs.min and crabs.max. That's all I was really checking there. So we want to go from crabs.min to crabs.max. And we're going to just map that to the amount of fuel required to move all the crabs to that position. Seems like a reasonable way to go. What do we do here? So for each position, we want to know the difference between the position, the absolute difference between the position of the crab and the position that we want to move it to. So we can take our crabs and sum them all up. So we'll have our crab, and it'll be position minus crab, and we're gonna want to take the absolute of that. Might work. Provide minimum. I called minimum instead of min. Expected to got 37. Oh, that's this. I'm getting the Is there like a min by? Yeah, I want min by. Unless it takes a block. Turns out, damn, there's really no Ruby min by. Oh, it's on enumerable. That works. Okay. So we can use that instead. Cool, that works. Let's see if we can get this right. Day 7, part 1. It says position 325. What's the solution? Not the right answer. Why might that not be the right answer? Oh, this math isn't right. Because my math's not right. Right? Yeah. I think so. So what I actually need to do is if crab is less than position, crab's less than position, then we subtract crab from position. Crab's greater than position. I mean, isn't that still the difference though? Crab's isn't what I did the same? That's 0. If crab is less than position, then it's crab, position minus crab. Otherwise it's crab minus position. That's the same thing. Same result. Yeah, that doesn't do anything different there. Okay, what could I be doing wrong? Then I'm getting the right answer for how much, how much fuel must they spend to align to that position? I did the wrong thing. Cool. That's just a classic reading comprehension. Okay. And so this is the actual answer is 37. So cool. That's that's an amount of fuel. Should be a huge number like that. Cool. Okay. Just failed to read the problem. Cool. Day 7, part 1 is complete. Let's go on and see what part 2 has for us. The crabs don't seem interested in your proposed solution. Perhaps you misunderstood crab engineering? As it turns out, crab submarine engines don't burn fuel at a constant rate. Instead, each change of one step in horizontal position costs 1 more unit of fuel than the last. The first step costs 1, the second step costs 2, the third step costs 3, and so on. As each crab moves, moving further becomes more expensive. This changes the best horizontal position to align them all on. In the example above, this becomes 5. Move from 16, okay. So now okay, all right, cool. So now we'll move on to day 7, part 2. Day 7, part 2 spec. The new expected answer is 168. Let's just grab our input again. I should really restructure these specs so I can just share the input. I don't have to type it out each time. Okay, so that's our day 7, part 1. Let's keep that around. Now we've got day 7, part 2. We should see it fail here. Cool. I mean, we just need to convert that into the fuel cost. Removing that many tiles, right? So fuel cost, and then part 1, just do that. Cool, and we haven't broken part 1. In this one, we'll re-implement fuel cost here. What should we do here? Is there an easy way to do this? What's the math for? There's a shorthand for this sum, isn't there? It's like n times n minus 1 over, something like that. N times n plus 1 over n minus 1, something like that. Am I close? How am I going to do this? Sum of consecutive integers formula. Yeah, I'm too far out of this. I just want from 1. I don't need the general formula. Give it to me. n times n plus 1 over 2. All right. N times n plus 1 over 2. Cool. Cool. That was fun. I'm glad that I knew the trick. That made it a lot easier. Part 2 was relatively easy. Stumbled a little on part 1, but we got there. Thank you, Jay Hawthorne, for coming out. Thank you, Jay Megathumbs. I'll see you tomorrow. And yeah, it's been a pleasure as always. I'll be back again tomorrow night, and hope to see you there. Cheers.